I appreciate everyone joining. By the way, just to clarify, I switched jobs. I got hired and poached by Polygon, so yay. I would like to just by a show of hands, who's new in Web3 or new-ish? I love you guys, because I was like, yo, I made this presentation, and I was like, people better be new to Web3, and so I changed. Let's see if that pointer works. So I changed it to, oh, you cannot see, but to beginners. Yeah, so real quick, I'm the regional lead, head of dev at Polygon for Europe. I've been about 10 years in the fintech industry. I do create educational content, but very much for beginners, Python, Web3 enthusiasts, and this is where you can find me. Today we will talk about what is Web3, a little bit of an intro, a disclaimer as well, because architecture, I assume we're all tech folk. Architecture is a wildly complex topic. It's not simple, even in Web 2. So we'll do some scoping, and I'll be clear there. And we'll talk a little bit about, okay, what is a blockchain? Also high level. The space is innovating like crazy at the moment. And sometimes when I talk to my friends in my previous companies, it's like they still have like a notion for a very simple example. Blockchain is very slow. Well, for a lot of things it's true, but that's being solved right now. So we'll talk about the major components. Then we'll actually dive into, okay, hey, Web 2 versus Web 3 architecture-wise, a simple use case. We'll dive specifically, that's a little bit maybe more deeper on-chain versus off-chain, which I believe is a very important topic in Web 3 architecture. And then I'm just going to end it with, this is just the beginning. I mean, this will give you a good intro. But it took me, I think, a bit to understand the value of blockchain. But once you understand it, once you're like, yo, you get it, decentralization no longer becomes a buzzword. So what is Web3? If you were here yesterday or any of the other talks, maybe you'll see this slide and be like, oh, I recognize this, but this is like the go-to slide. Web 1, we got internet. We were able to search things, so if someone claimed something, you didn't have your mobile phone yet, but you could go back home and say, I don't know if that's true. And Web 2, social media took off, mobile took off, websites look better, and I think the key difference was we started to interact with each other, share information, and with that, let's say in a Web 3 notion, centralization happened. Big companies, they owned our data. I won't say it's necessarily evil, it's just that this is the natural transition what happened. We wanted better feeds, we said things we liked and didn't like, so the algorithm catered for it, and the only way you could cater for it is by knowing our data. So Web3 has actually many definitions, and I think traditionally, like when people spoke about the Web3, like it's in the next phase of the internet, we thought advanced AI is also part of it. But right now, Web3 is very much like consumed by blockchain. And blockchain, as it says, read, write with ownership. And that is facilitated by blockchain technology, and we'll get into that. And decentralization is a huge component. And in Web3, blockchain basically does two things: decentralized data, and you own the data, you can certify it, cryptography, etc., and fast payments. So now for a disclaimer. I've got 3 disclaimers I would like to make. Already, as I said, architecture on its own is a complex topic, even in Web 2. Highly respect solution engineers, solution architects who come up with design patterns, strategy, goals of a company. These all things like influence an architecture. And like there's no way I'll be able to do in 30 minutes go over very complex patterns. The second disclaimer I would like to make is, I'm not going to dive into mechanisms such as proof of work, proof of stake, sharded stake, or proof of authority, and really like how does a blockchain process data and etc. It's really going to be more like a pattern and comparing Web 2 versus Web 3. And then finally, the disclaimer I'll make is, I'll start with decentralization. Yes, it's very important, but you also always need to look at the use case, saying, okay, hey, does decentralization make sense or not? I will say though, the longer I'm in the space, the more and more I'm starting to think, hey, I mean, decentralization, yeah, it makes sense there, it makes sense there. So maybe it's also Web3 folk living in the Web3 bubble, but I do highly believe that we need it more and more. But Web3 is an expansion of Web2. That's one thing I firmly believe. So, what is a blockchain? Well, a blockchain has mainly, and this is high over, two components, major components, I would say, storage and execution of code. So storage-wise, it's a distributed database, a ledger actually, but I'm not going into that, but distributed database shared among nodes of network. And every node, technically speaking, has a copy of the database, which allows us to verify accurate data. And if you're interested in the actual data structure, they're a linked list, basically, in the form like every block knows what happened before and after it. And then this is basically the visual representation that I like to show, because when I started to learn about blockchain, I was like, okay, blockchain. It was very difficult for me to grasp. I know service, I know cloud, I know where your data is, but what did it mean it's a node or a peer-to-peer network of computers? Well, what it actually meant is exactly, what people said, or what was being explained, is that it's a network of computers and anyone can spin up a node, which is pretty insane. So you can go to ethereum.com, the foundation, and website, and you can download a full copy of the database and then run a client, and then you can participate in a node. I will not go into the details of how to participate as a validator and or how to just participate in a network as a regular node with all the ETH staking that happens. But probably the first thing I thought was, wow, the performance must be really bad, because everyone has like one full node, like the whole full database. Yeah, it's like one of those limitations in blockchain that's being solved right now. But I think this is the very meaning of decentralization. So it's a network run by, I would say, community or the people around the world, and everyone can participate in it, and that's how decentralization is safeguarded, partially that way. I mean, obviously as well through the cryptography and the way the data is stored across the network. And then the second major part is smart contracts. So a blockchain stores data and then it can execute as well. If you, even Bitcoin could do that, but Bitcoin could do it in very, very simple scripts. It wasn't very advanced. And when Ethereum came along with EVM, that's when things really took off, because now you could have smart contracts that could do more than extremely simple stuff. I mean, I like this statement from IBM, because smart contracts are still very simple programs. They're stored on a blockchain and that run on the virtual machine when predetermined conditions are met. I was last week in Berlin, and there was a presentation. It was much more fun than mine, and it said, smart contracts are dumb. And it's kind of true, because it's a very, in essence, I mean, smart contracts can go very extreme. Like if you look at any DeFi protocol, a decentralized financial protocol, they have very complex smart contracts. But in essence, you could decode it, I guess, to very, or destruct it to very simple programs. All right, so now that we've defined, going a little bit fast, but now that we've defined what a blockchain is, what is Web3, you could say, okay, hey, let's compare it to Web2. And I guess I got this from Pritika's blog. I think I like it because it's extremely simple. Obviously, auth layer, API layer, there's stuff missing in here. If you know the traditional pyramid one with the different layers in architecture, infra, data, etc., it's all missing. This is a very simple front and back end. I think most people will recognize it, how a user interacts with a simple website. This was how it would look in a Web3 version, where, just as I explained, let's start with the lower part, the back end, what the back end replacement and database is. You have the storage, which is the blockchain, and then the virtual machine, which executes a smart contract. And then, I mean, in the pictures, it says smart contract with the pointing towards the virtual machine, but obviously that's stored on the blockchain itself. And then you have your front end, just the website. Someone comes in to the website, and they're trying to interact with your app, or decentralized app, dApp. And the way they do it, they need to connect to the blockchain, and a provider provides a method, an RPC URL, to connect to the network of nodes. And I'm just going to go over here. This is just a simple code. I'm not going to do like a tutorial here, but I guess I would like to point your attention to here, like what it looks like. So this is to give you a picture what it looks like. You have a RPC URL, which is basically your connection, and you can compare it to an API call. made to the network. You instantiate your connection, and then all it does is over here is I pass a wallet address, and I basically get the balance of that wallet address. So reading information is very easy. You don't need a wallet for reading information on the blockchain because you're not modifying anything on the blockchain. So if I go back, you see over on the top right is the signer. It says signer. It's a MetaMask. It's a wallet. By show of hands, who knows what a crypto wallet is? All right. So, okay. I would say a lot of people actually do know it. So as you know, it's like a method of logging in. The way I would explain to the people who didn't raise their hands is it's not entirely one-to-one, but it's like having a bank account with a PIN number. You know, you have your bank account, you have funds in there, it's an address. That address is not publicly known, just like your wallet address, but I mean, it lives around. And then you have a PIN number, and with that PIN number, you can access your bank account and any funds in there. And with a crypto wallet is a little bit the same. It's like you have a public address and a private key, and with that private key, you can access any funds linked to your wallet address, because technically speaking, they're not in the wallet. But and so that's a little bit of a comparison. And then your wallet is actually like your ID, let's say, on chain, and the way you interact with decentralized applications. And here again, you could see like this is what an address, for instance, on this one is Mumbai, so Polygon looks like Ethereum, say. So here you can actually see. I would like to divert your attention to these two parts of the code, where you can see what if I want to modify data on the blockchain. So, or you want to create a transaction. When you create a transaction on chain, so when you do something on chain, you write data. Let's say you execute a smart contract which sends tokens or crypto. You pay gas fees. I'll get to that in a bit. But you sign a transaction, and in order to sign a transaction, you need to use your private keys, which says, "Hey, I own the wallet," and you cannot see the private key because in another file it's stored. So if you ever dealt with API keys, you know, environment variables, I'm passing them instead of like typing them here in the code. Again, this is a very simple Python script, but with my private keys, I say, "Hey, I signed the transaction," so the blockchain can verify. Raza has approved this transaction, and then I send some tokens, and then you pay gas fees. Gas fees are fees you pay to the network to process your transaction. Extremely simple point. So this is a little bit what that code looks like. So two things you can do on chain. You can read data, free, anyone can read data. Once you want to write data, you modify the state of the blockchain, so to say. So you write data on chain, and then you need to pay gas fees. This is a comparison. It's not the one-to-one because obviously like login here and auth is missing, but it's to give like a visual representation. So then coming to the use case. This is a thumbnail by Morales, a YouTube channel. They've got great content on how to build decentralized applications. And here they said, okay, hey, let's build a Web3 Twitter clone. You know, a Web3 Twitter clone, before I go like in more or less the diagram, and I'm not making a political statement, but when Trump got banned from Twitter, obviously it was a statement, and it's a very prime example of, I mean, a platform, they can do, you know, technically speaking, what they want. Now, obviously, there's a much more sophisticated process before that happened, and this is not a philosophical or an ethical talk. It just shows you that decentralization has its place, and that's why I like this diagram. It's from a Coinbase blog by Emre, and it shows you very simple, actually, what would happen if you would integrate Web3 in Web2. So on the left, this is very much like, I mean, I think recognizable, where you see you have an application front end, so a user comes in, and the way they interact is, so any simple API calls, you know, a crude application, so create, read, update, delete. Someone comes in, when you tweet, what actually happens is you make an API call to the backend, and they store that information for you. So, I mean, details there, but so this is basically what that happens is, and then here is where your data lives. And then in a Web3 fashion, you wouldn't log in, let's say, with your single sign-on with Gmail, but you'd come in and you'd be recognized through your wallet ID. So, you know, you come in, or your wallet public address. So you come in, connect with the application. Is this visible? No. So on the top right, you come in on with your wallet, you log in, usually by signing. So you could also I will not go into the details of that. But you can usually, when you come into an application, you can sign, and then the application says, yes, you do indeed want to connect to this website, and they can retrieve information with your permission. And then this is how the interaction happens. And then in this specific application, what happens is every time, so reading data again doesn't cost gas fees. So you could read data of the blockchain, so the data would be stored here, and maybe some credential information would be stored here. And when you write data, depending on how you want to structure it, you could make sure your tweets live on chain. Now, every time you would tweet, you would create data and store it on the blockchain, so you would pay gas fees. Is it optimal? Probably not. I mean, if you could go to Twitter and you want to tweet whatever you want, it doesn't technically cost you money. If you go to, let's say, decentralized Twitter, and now you're tweeting, and every time you tweet, you pay gas fees. I mean, I'm pretty sure most of us would not be interested in that, even though you would own your data. So there are actually ways that are being innovated at the moment to change that, pay less gas fees, extremely less gas fees. You see platforms that actually pay the gas fees for you. So they're like, you know what, I just want you to be here, and I'll make sure that you can do whatever you want, but I'll pay the gas fees for you. But it's just to show you that there is let's say, a trade-off when you want to decentralize stuff, because a blockchain operates different. Which actually brings me to the next topic, is that we kind of agree decentralization has a place. We don't maybe want our data to live in a database somewhere owned by someone. What is the alternative? And actually, when NFTs were being created, hate it or love it, is that the asset lived on-chain prior. So on the blockchain, you would have actually your image. Not going into like how an NFT is structured, but technically speaking, if something happens to the image, your NFT is rendered useless, because there's no way for the blockchain to validate actually all the components in the NFT. So the only thing you could do is either make sure you have a URL or somewhere where that image is stored and it never ever changes the place, which would be like an S3 bucket, and then you actually do have a problem, or on-chain, which it costs a lot of money to put it on-chain if your file is bigger. So enter IPFS. IPFS stands for Interplanetary File System. And basically, in simple layman terms, it's a decentralized network of nodes that all they do is storage. And basically what that allows you to do is you don't have to keep your data on-chain. If you don't want to keep your data on-chain, but you also don't want to keep your data in a database, then what you could do is say, okay, I go for an IPFS service. And there are IPFS providers, such as Pinata and others, Filebase. And what they actually do is they actually have like a node running, a network of nodes running all over the world, but it's just not blockchain. And there you can store your data. It doesn't execute any code, it just stores data. So this is a paper by Sejin Park for a decentralized application for car insurance, where basically here you can see a very, very, very simple overview where you have smart contract, where let's say I hit my car. If you hit car and want to make claim, then that kind of code lives on blockchain. And then let's say the variables you need, so your address or I don't know, your details of your car stuff, that's been pulled from inside the application from IPFS. And in that way, if you would like things you do not necessarily need to store on chain, you could have IPFS for that. And there are other use cases to this. This is like something very, very specific. So that's IPFS. And then, finally, that was actually the overview and talk on, let's say, the basics in Web3 architecture. But this is actually shows, it's also from the Coinbase blog, a good article by Emre Tekiselp, of the different components, let's say, in a Web3 dApp. It's actually much more complex. And right now, what we're seeing is, I'm not sure if anyone visited any of the other talks. You could, I think another today spoke about the modularity of blockchain. It's really changing and changing fast, because there are limitations in blockchain, such as high gas fees on Ethereum, a long game Polygon, another chain, also an EVM-based chain, but much lower gas fees. As I mentioned before, a major critic of blockchain was you cannot keep up with transaction speed on the speed of credit cards? Well, right now what we're seeing is with modularity and ZK EVM, so zero knowledge proof, those are being tackled. So there are alternatives coming out, and decentralization is becoming more appealing now because, hey, what if I have to tweet but I don't have to pay gas fees? Because a platform takes care of the fees. What if I can tweet and it's reliable and scalable? And also, I would like to point out that there are probably many caveats to what I spoke about. Like in major building blocks, it remains the same. I do believe, especially if you go back to here, I mean, this is not the end-all, be-all. I really like this blog on Coinbase because it's just an example. But I do think that integration and expansion is like the emphasis of where Web3 will live. And for many applications right now, to give you an example, one of our clients, they are a platform where you can take a picture of your homework and it sends it to someone else. A student can do that, and it sends it to a tutor. And once they connect to a tutor and helps them, they basically get a reward. But it's just a digital coin on their platform, not blockchain at all. And then they went and integrated blockchain. And now it's an actual, let's say, cryptographic token. And that becomes an economy on its own, and you can actually earn crypto coins, through helping others. Great platform, 500,000. They're called EZA. But that's like a prime example to me of someone they're just doing what they're doing. They have a value proposition, and now they're going to integrate a component of blockchain or blockchain as a component, and that made it possible. Yeah, I mean, this is not the end-all be-all. It's like to show you, okay, what if you had a stack on the left hand, and then, technically speaking, Web3 is just an expansion of Web2. I mean, there's a lot missing here. They'll call me on it. And this, I think, this is an overview which is by far incomplete. But if I would show you everything, I'm not sure if anyone has ever seen all the cloud tooling or everything that happens in the cloud environment. There's so many icons, it's not readable. It's the same actually already for the Web3 environment. But over here you can see on the different layers, who are the providers, the different chains, the interaction layer, the querying of the data, and the presentation layer and the application layer. What you're also seeing is right now is you see certain parties crossing layers. I talk to parties all the time, and like, oh, so you provide query services. No, not entirely, not exactly, because they also do a bunch of other stuff. But yeah, this one is from Alchemy. They're a node provider. Actually, that was it. Thank you.